In the last video, I show you how to create an interactive toolbar for ipyleaflet, and we also integrate ipy file chooser into the toolbar so the user can use the tool to open a vector data, for example, a shapefile or GeoJSON on their computer. In this video, we're going to continue to build upon the toolbar that we use and to integrate WhiteboxTools into this toolbar. So next, let's go to the website to download the notebook example we're going to use in this video. Head over to geodemo.gishub.org and then click Notebooks, Whitebox, upper right corner, click, and you can download the notebook to your computer. After that, you can open your Anaconda prompt or your terminal. And then you can activate the Conda environment that you created. So lowercase conda activate demo, and then type Jupyter notebook, enter. Then you can click the notebook to open the Jupyter notebook. So this is the one we're going to go through. You can click the table content if you want. We have 3 sections in here. So before we get into the details how to use a white box, I want to give you a brief introduction. For those of you who are not familiar with WhiteboxTools, it's a geospatial analysis platform that you can use to analyze all kind of geospatial data, vector data, raster data. You can think about that as kind of a toolbox. If you have used ArcGIS, for example, ArcGIS toolbox or QGIS toolbox, so those toolbox integrated with the software. WhiteboxTools basically is also a toolbox, but it's an independent toolbox for geospatial analysis. That means you don't need to install any desktop software like ArcGIS or QGIS, and it's very small. The file is only 10-20 megabyte compared to desktop GIS software. For example, ArcGIS might be several gigabyte, and QGIS also pretty big. So it's very small, and it's cross-platform, so you can run it on Windows, on Linux, or Mac OS. And it's very easy. You don't need to install anything. You can just simply download the binary, pre-compiled binaries to your computer, and then you just unzip the file. Then you'll be able to run the program. So it doesn't install anything to your computer, and it's very powerful and very efficient. So if you have not tried this, I highly recommend that you try it out, and we're going to use that later. So this is the GitHub webpage. You can go to, it's developed by Dr. John Lindsay, and he has been a pioneer in the open source GIS community. So previously, he also developed a Whitebox GAT, and also right after that, that one is kind of also similar to like a desktop GIS software, but after that, the Whitebox tool basically makes it independent, so it can run on multiple platforms, and you can basically integrate this one into your geospatial analysis pipeline using Python or R or ArcGIS or whatever platform you want to use. You can use that with all kind of software packages. And if you want to learn more, you can look at the details. So this toolbox was developed using the Rust language. So I know many of you probably know this language. So it's kind of a relatively new language, but it's also widely used in system programming. And if you want to learn more about the source code, you can look at the source code. So all the source code will be the file extension is RS, and you can look at the source code. So this package WhiteboxTools right now has 477 tools, and it's like a huge toolbox. I highly recommend that you try it out. You will be amazed by the speed and the efficiency of the program, and I'm going to show you later. So this is the WhiteboxTools. It basically is a command line, so you can download. For example, you can go to the release, and then if you scroll down, here you'll be able to download this one to your computer. So look at the file size. 6 megabyte, 4 megabyte, 6 megabyte, and it contains almost 500 tools. It's just the file size is very small compared to ArcGIS or QGIS. So for example, I can just simply download this one to my downloads folder, and then you can simply unzip the file. So I can just maybe unzip to the folder here. Then you can get into the folder WBT. So that's it. This is the exe. So after unzipped, it's 27 megabytes. So it's still pretty small. And after that, you can just simply open your terminal. Then you can start writing, executing the command to do geospatial analysis just using the command line. So if you want to learn more, you can go to the website. You can scroll down, for example, to see how to get started. For example, if you want to look at help, or you can run a specific tool. There are a lot of information here, but it's standardized. So yeah, all the tools, because it's using the toolbox, so all the tools you can run very much similar using the similar command. So you can look at this kind of a command here. You can set the working directory and what kind of tool you want to run, and also the input and output. So let me give you a quick example. After you open the terminal, then all we need to do, right? If you look at the file here, so this is the exe, the binary used to run analysis. So you can just dot and then forward slash and then white box. You should be able to see this one exe, and then just -h. You should be able to look at the help. You can also look at, for example, all the toolbox, or you can also view the source code. For example, you can just list all the tools, right? So if you dot WhiteboxTools and then ll hyphen list tools, and take a look how many tools, right? 477 right now. So it's a huge list. Most of the tools, for example, in ArcGIS, many of them actually are being implemented. So this is open source. That means you can look at the source code of every tool. But if you're using commercial software, you won't be able to see the source code. So if something goes wrong, you might need to wait for somebody to help you out. But if you're using open source packages, something goes wrong, you can look at the source code and trying to understand in more detail. So you can see, for example, every source code. Anyway, it's a very powerful geospatial analysis platform. So I highly recommend that you check it out. And so besides the white box tools like command line, there are also some like front end. So you can think about the white box tools as kind of a back end, computing back end behind, but there are a lot of front ends you can use because it's just a binary. It runs on all computers. So we can use other computer languages actually to call those executable file and then to run analysis. So, and you can look at here, we have Python, we have R, we have Jupyter, we have ArcGIS, we have QGIS. So basically we have this cover in most of the computer languages and GIS software packages. The first four here, Python, R, Jupyter, and ArcGIS, I actually developed this front end. So basically I expose the API using these languages so user can easily use the WhiteboxTools geospatial analysis platform, and you can utilize, enjoy the benefit of, for example, auto completion. If you're using the command line, it's very difficult because you need to know exactly what's the name of the tool and also how to provide the input and the output. And it's a lot easier if you have integrate into other computer languages. So Python and R is still provide as functions. You can call the functions. For Jupyter, you have an interface, and also ArcGIS, you have a toolbox. I recommend you try this out. For example, you can click the link. If you're using ArcGIS, you can take a look. You can look at the toolbox. Very easy. Just download the toolbox, unzip to your computer, and then you'll be able to connect to the toolbox and look at it here. It's just like a normal ArcGIS toolbox. You can also use ArcGIS Pro. It was the same way. Okay, so look at the list of tools in here. Very powerful. So for this video, I'm going to show you how to integrate this one into your geospatial analysis pipeline so that you can run that on anywhere. So we can run it on a Google Colab or in the cloud. If you're using ArcGIS, you're out of luck because ArcGIS doesn't really run on in the cloud. You need to install that one. Okay, so next, let's go through some of these things in here. The first one I'm going to introduce is Box Gui. So it's basically WhiteboxTools for Jupyter. If you click this one here, if you go to the GitHub repository, you should be able to see the source code. So this is the one I did a couple months ago, and it's basically to bring in the interface for Jupyter Notebook so that you can use the 477 tools without having to write any line of code. You still need to write 2 lines of code to show the interface, but it's very easy to use. So as you can see from the example here, once you have these 2 lines, you have a toolbox, and then you can use the toolbox to do geospatial analysis. If you want to look at the source code, you can. If you click Whitebox GUI and then whitebox.py, here you'll be able to see the source code. So this one is not as complicated as the Gmap package that I developed, but it's still quite a lot of work, almost 900 lines of code. And this is basically how to, based on a command line program, how to create interface, how to create interactive widgets, so that user don't have to write command line to execute the source code. And you see here, it's, if you want to learn more about the source code, look at this one. So only one single module, pretty easy. And so next, let's just go through here. Also, if you want to try it out, you can just click the link to run in Google Colab. Once you open Google Colab, you can just install the package and then import the library. Then you'll be able to show the toolbox. So I'm just going to run that here directly within my Jupyter Notebook. So first, I'm going to import the library. By the way, so if you're trying to integrate this one to your package, make sure that you also include this one in your requirements.txt. So for example, the GeoDemo package, right? So if you go to the GitHub repository and under the requirements.txt, make sure you have this one added. Otherwise, you might run into errors when you're trying to build the package from GitHub. Okay, so import the library and then just whiteboxgui.show, and then it's going to show you the toolbox stages. So if you see right now, right, we have a toolbox, and this basically the tool set similar to ArcGIS, like spatial analyst toolbox or hydrology or 3D analyst, and this is the same. So if you click all tools, it's 444 tools. So this one was created using ipyWidget. Okay, so we introduced ipyWidget in the past videos, right? So if you see from here, but we only did some very simple interactive widgets. But this one here is a bit more complicated, and you can see when you click the toolbox, it's going to, on the right here, the middle column going to show you all the tools available within here, and on the right here shows you the interactive GUI for each specific tool, right? And you can see the description. You can select the input, right? So it's going to show you here the input, and you can also, for example, select the output, something like that. So it's very easy and to use. You can also click one, also click help. Click help is going to navigate to the source code, and you can look at the WhiteboxTools menu to show you all the source code. You can also look at the real source code behind the scenes, and then also you can click the import. So if you select all the files and then you click import, it will going to create a new cell block beneath, and then so that you can use that to in your source code without having to use the interactive GUI. That's also one thing that's very useful. You can use the GUI to basically play with your data and try it out. After that, then you can use this in your command line without having in the Jupyter Notebook source code without having to run the GUI. Okay, and also this is one of those, but I also provide another way using a tree structure. So whiteboxgui.show, and then there's a parameter called tree equal to true. This will give you another version, but it's the same toolbox, but just different representation. So this one here, because this one based on the so-called ipytree package. So ipytree is not supported in Google Colab. Okay, so it won't work in here. But this one is basically better. If you look at this one here, you can click and it will show you all the tools. If you select any one of those, On the right here, I'm going to show you the toolbox. So basically, it combines these two together. I personally I like this one better, but Google Colab does not support this, so that's why I provide both versions. But you are welcome to use any of those. So once we have the toolbox, then we can maybe run some tools easily to see if we can get basically do some simple testing. So okay, so next let's download some sample data. If you have, you can go to, for example, the geo demo package website, and then examples data. So in this example, I'm going to show you how to load convert a CSV with a longitude and latitude into a swap file. So basically from a CSV file to a vector data set, and you can click the file, or if you have something on your computer, you can just use any file you want. So this is the CSV. I'm going to click the raw button, and then going to download this one, for example, to my downloads folder. After that, if you want to open to take a look, it's fine. So in here we have 5 columns, right? So all the cities are around the globe, and we have longitude, we have latitude. Keep that in mind, we need to know the index because we need to find out the column index, which one is latitude, which one is longitude. Okay, so let's go back to the Jupyter Notebook, and then from here, you can search any tools. So for example, if you click all tools, and then if you search tool, so for this one, because it's CSV, so it might be something CSV to points or something, you can just type CSV, okay, and on the right here it shows you the result. CSV points to vector, export data to CSV, or merge table with CSV. So the first one here is the one that we need, right? So, and once we click this one, on the right here shows you the name of the tool. If you want to look at the source code, you just view the source code. It will take you to the WhiteboxTools web page, and you can look at the source code. This is kind of a simple tool, but behind the scene, you see how many lines, hundreds lines of code actually is needed actually to write something like this. So just keep that in mind. If you have a couple hundreds of tools, this gets quite complicated. Okay, so next let's select the input, and this, if you select the input, so this one is what we're going to select. We're going to select the world underscore cities.csv, and then click. So for the output, similarly, you can select the output, and I'm going to choose the name, for example, cities.shp. Then you can select the next one here, x feed number. So x basically is horizontal. So horizontal, that one is longitude, right? So longitude and latitude by default is using 0 and 1, but in our case it's not. Okay, so longitude here, right, starting from 0, 0, 1, 2, 3. So the index of the longitude is 3, and then the latitude will be 2. What we need to do here is actually to change these two numbers. So it will be 3 and then 2. After that, you can also enter the EPSG projection. So the European Petroleum Standard Group, and this is kind of a projection. You can Google online, go to, for example, spatialreference.org, you'll be able to find it. So in this case, because it's just longitude and latitude, it will be WGS 84. So the EPSG number is 4326 26. So all you need to do is just to enter this one, and then you can just hit 1 and take a look. Like even with less than 1 second, it's done. And you will see here the command line. This is actually the command line behind the scene to execute, to run the source code, the input, right, and the output, and also the XY indices, also the EPSG, and look, okay, and also see the progress. Very, very fast. You will be amazed. Way more faster than ArcGIS. Also, if you want to, this is the source code, right? If you want to see the Python source code behind, you can click the import, and then from the import, it's going to show you what kind of tools actually used to run this. So it will be import whitebox, and then create the WhiteboxTools. Then you call the tool. From there, you provide the input, provide the output, and this is kind of a long line in here, but this is basically the source code. You can get the same result just like this one. So if you want, you can click this one, you can run, you'll be able to get, okay, so this one here, because we're using Windows computer. So the backslash, you need to basically put an R at the beginning, raw. But if you're using Mac or Windows, Mac or Linux computer, you probably don't need this one, because the escape is a special meaning in Python. So you might need to put R at the beginning, and then you can click one. Again, you get the same results in here. That's 0.1 second. After that, you can come back to here. You can go to the downloads folder. You'll be able to see the file, right? And then you can use this file. You can open using ArcGIS or QGIS or any other tool you like. I can just open maybe QGIS. But later, I'm going to show you how to integrate this one into the package that we're developing, so that you don't need to user can just open the file and then load it on the map directly within Jupyter Notebook. So this is a simple example how to use the GUI, and you can try it out, see if there's any tool that you like. For example, hydrological analysis or stream network analysis. Many of those tools, actually, you won't find these tools in ArcGIS. So this will give you a lot more options and more dedicated one, useful tools you might want to use. So this is for the Whitebox GUI, and the next one here basically is Whitebox. So Whitebox GUI actually built on top of Whitebox. As you can see from the source code that I show you in here, this one actually is built. The GUI is built on top of the Python package called Whitebox. Again, it's also the one that I developed. If you want, you can go to the GitHub webpage to look at the source code. The Whitebox. This one has a little bit more, but it built on top of the Whitebox runner provided by Dr. John Linji, but I make it basically easy to install and maintain. So it's also available on PyPI and also Conda. This one here shows you the simple example. You can import the library, and then you create the WhiteboxTools. Then you can run any tool. So for example, let me quickly go through the example. And then we're going to use the sample data set. For example, the package comes with some sample data set. If you want, you can, for example, you can look at where the data set is located. So this is where the sample data set is located. You can copy and then go to your Windows directory, File Explorer, and then paste, enter. You'll be able to find the file. So the sample data it contains a dm.tif. The DM you can use to do some analysis. So in this case, we can retrieve the DM, and then after that, you can set some output directory. So where you want the file to be saved to your own computer. We are going to use the downloads directory, and then you can set the working directory. That means all the files, if you don't provide the absolute path, is going to save to this working directory. Also, the variables are equal to true. That means you want to show some descriptive information when the program is running. So for example, progress from 1% to 100%. Those are basically the variables controlled by the variables parameter. And then after that, we can run any tool. So you can just create a new cell, wbt dot, and then press tab on your keyboard. It should bring up the list of tools. So if you see from here, these are all the 477 tools right now that you can select. If you want any tool, you can just click and then parentheses, shift tab. Then you can see, for example, what you need to provide. So the input and the output. The callback here, you don't need to provide. So this is how you can run a specific tool, right? So similarly, if I'm trying to run the one called feature preserving smoothing, then you can do it in here, parentheses, and then shift tab on your keyboard to bring up, right? You can see all the parameters. So this is how you can use this package. It's very easy to use. So just follow the example here, and then you can run any tool on your computer. So in this case, we're going to use the so-called feature preserving smoothing. We're going to smooth the DM and then save the result as smooth.tif, and the filter 9 is basically how many rows and columns. Basically, it's a moving window 9 by 9 to smooth the DM. So we just shift enter, take a look. Less than 1 second. Scroll down, right? 0.02 seconds. You're done. The DM. If you want, you can open here. You can double click this one, and if you want, you can drag the DM to QGIS. This is the DM, and you have the result, right? The smooth. And come back to here. You might not notice too much difference right now, but that DM might already be smooth. After that, we can run the second one, bridge depressions, right? Go into bridge, basically fill the depressions. If you use ArcGIS Spatial Analysis, you might be familiar with this one. Again, very quick, and you get the result. Lastly, you can calculate the flow accumulation using the bridge DM, and Control Enter. Done. After that, let's go back to the results here, and you can drag this one to your QGIS. You see here, this is the flow accumulation, right? You can use this to extract stream network if you want. This is a simple example. You can apply to any other data set that you want. Okay, so this is how you can use Whitebox GUI and also Whitebox. The next one I'm going to show you here is how to actually integrate this one into ipyleaflet and to build on top of the toolbar that we created in the last video. Okay, so what you need to do is to import the GeoDemo, right? So this is the package that we have been working on, and then import the Whitebox GUI as WBT. Also, like I show you in the previous video, if you want to add any tools to ipyleaflet, it needs to be as a widget control, and then the widget control has the widget, also the position, and this is how you can add the one into the map. But if you see from here, we also use a couple more functions. You can basically use this. You can, if you want, you can just import a Whitebox and then Whitebox GUI. Let me maybe clear all the output to show you. If you just want a simple one, you can just use these two lines. But the reason that we want to make it more complicated is that this one is too big, so the widget is too big. If you have a ipy widget, you have a map, this is going to cover the entire map pretty much. So we want to basically make it smaller to fit the toolbox into the map, and that's the reason why we want to, for example, control the width and also the height, so that the toolbox is not too big to put it on the map, right? So this is the map. If you have the toolbox like the default one, it's going to pretty much cover the entire one. So we're going to get basically the dictionary of all the tools, and then use the dictionary to automatically create the toolbar GUI, and then we can add this two widgets to the widget control, and then add to the map. So take a look. Once I execute, now this one is basically resized. It's a bit smaller compared to the one that we saw in here, right? Slightly smaller. And if you see, you can click, we can go through. So this is how you can directly add this toolbox onto the map, but it's not integrated into the toolbox yet. It's still oh, it's already integrated. Okay, so let me close in here, and let me add one more time. Close this one. So once the Whitebox tools is being added to ipyleaflet, I can select any tool, right? And similarly, I can run analysis directly within the book, within the Jupyter notebook. This is nice because if you deploy this one to the web, and user will only be interacting with your map, they won't be able to execute the source code. But if you provide as a toolbox, user will be able to, for example, select the file. And again, I'm going to go to the CSV that we use, and then click. You can output the file. So this one, maybe I choose to cities.2.ssp, and then select enter again, enter 3, enter 2, and then 4326. Just click 1, and then you get the result. So everything is basically integrated right now within the toolbox. You can maximize. The toolbox will be showing at the lower right corner. So this is how you can integrate the toolbar into the ipyleaflet. And so next, I'm going to show you how to basically integrate this one into the package, so that when the user create the map, they will have the tool directly within their disposal. So let me clear everything in here just to show you what the final output look like. So run this one, and here's the toolbar. If you click the toolbar and then you click this one, kind of like a toolbox gears icon, and then if you click, okay, so now you see this one, pretty nice. This is actually very simple and easy to use, right? If you click this one, you have this toolbox. So how can you actually integrate this one into your package? Is that you need to add a function to when the user click this button to execute something to show you this one. So how can we do that? You can go to, for example, you can open the source code where it is. Let's go to the website here just to show you quickly. Go to the GeoDemo repository. So again, the first thing you need to do is to add the Box Gui into the requirements.txt. After that, you can go to the GeoDemo and then the toolbar. So from the toolbar here, if you scroll down, this one is the master branch. Actually, I haven't added this one yet to here. It's under the Whitebox branch. If you scroll down, and then so essentially just edit this one here. If the icon equal to gears, so I changed basically the icon. Maybe let me open using Visual Studio Code. It will be easier to see the results. Okay, so if you click this one here, the toolbar again, if you scroll down to the here, this is what I changed from the last video, is to change the icon. So the first icon that I changed is to change the icon to this one, the gears, and then here I added this section. So if you see from this one here, so if the user click the toolbar, if the tool icon equal to gears, that means the user click that tool icon. We are going to basically import the Box Gui, and so these sections are pretty much exactly the same like what we did in the Jupyter notebook. So we just trying to simulate this, how to add this one to the map, and then when the user click, they will be able to have this one. But keep that in mind, when the user click, if they close, you also need to remove the control. So by default, it's showing at the lower right corner. So if you see from here, right now, if I close, if I open this one again, it will always be here, right? If I close, it will always at the lower right corner. But the reason that it's always at the lower right corner, because we remove the control in the source code. If you don't, if you just use this way, let me show you. So after I close, right now you see it's up a little bit. So if I close, every time you should add that one here, it's moving up and up. So the reason for this is because the control actually is still there. It's not removed from the map. So if I close, that means you have many controls right now on the map. So it's moving up a little bit more. If you can just type m.controls and then Alt enter, you might be able to see this, right? Actually, it's very long because the toolbox is actually just being hidden. It's not being shown, but it's there all the time. So that's the reason. So when the user click the close, you want to make sure that the control is being removed. It is already there. So let's come back to here to Visual Studio Code, and I show you here. When we add the control to the map, we also pass the control to the as an attribute to the map. So we have the attribute called Whitebox. The first time that you run, it will create this one, and the next time when the user click again, it's going to detect, okay, whether the toolbox exists or not. Is it still on the map control? If yes, it's going to remove the control. So in this case, you only have one toolbox on the map, and the toolbox will always be shown at the lower right corner. So if you just use this source code, it's every time if close, it's actually still on the map. So it's just moving up and up. It's very annoying. So, but if you just use this way, let me show you here. If I click, okay, lower right corner, if I close, it will always be there, always at the lower right corner. So it doesn't impact the position of the map. So this is just the slight difference from the source code compared to the one I show you in the Jupyter notebook. So this is basically how to integrate the WhiteboxTools into ipyleaflet so that you can use that for geospatial analysis. So this is just as you only need to make these changes, and I don't believe that I need to do anything with the toolbox. So again, once you, for example, once the user, let me do it one more time here, or you have the toolbox, and if I click, right, so we have the tool, and then we can just maybe maximize here, and then click the data tools, CSV to vector, right? I can select the file from my computer, the CSV again, one more time, and then I can just, for example, cities street.ssp, select, and then again this will be 3 2 43 26, then click run. Okay, so we have the result, right? So this is basically right now a vector data. So with the vector data, then we can let me close this one. We can use this one that we developed in the last video, right? So we can click the open icon, select, and under the downloads directory, right? So cities 3, select, apply. Okay, so now we have all the points, right? So we convert a CSV into a vector data, and then we can use ipyleaflet to add the vector data to the map. Okay, so this is how you can actually integrate other open source packages into your package to do geospatial analysis, to do visualization. This is a lot of points. You can actually use the marker cluster if you want to actually to make it much nicer, because right now this one is just simply creating just markers. It's overwhelming if you have too many points, but there's still a lot of room for improvement. This video is just showing you how you can integrate, build on top of other geospatial packages, and to provide functionality for you to make it easier for users to use that. So in that way, it's less intimidating, because if you're just using the command line, many people will be scared. But if you're using this way, right, no coding is actually involved in here. It's just simply just click and click one analysis, then you open the toolbox. That's it. Simple and easy to do. Once you get familiar with the whole procedure, right? So in here, we right now have the 4 tools. You can add more and more. It depends on how many tools you want. You can make 3 by 3, 3 by 10. You can expand the toolbar, and then for each tool, you can integrate some other package. For example, GeoPandas or Xarray or raster.io. This example is just showing you kind of a general workflow, but there are a lot more things you can do to build on top of other packages to make your package more powerful and easier to use. And once it gets out there, if people find it more useful, you want to get more and more users, so you can continue to build the package and to streamline your workflow, but also help others. Okay. So that's all for this video. And if you try out Whitebox, if you like it, you can. If you're R user, you can use the Whitebox R. If you're QGIS user, you can also use the QGIS plugin, or the WhiteboxTools ArcGIS tool. If you have any question, you can leave a question or open an issue on these GitHubs. They are all open source. So if you want to learn like how I actually build this front end, you can look at the source code behind the scene. For example, how this WhiteboxTools, how so many tools are actually created. This is basically all using the automated procedure. So I write the source code to read the command line, and then to get the tool, get the parameters, and then use the parameter to automatically create the toolbox. Okay, so I don't, for example, in here, if you look at the toolbox, okay, so we have almost 500 tools. I don't develop interface for every tool. It's going to be a lot of time, but basically I write a program to automatically detect, automatically create the widgets like this. So because every tool has parameters, and you just need to read the parameter and also figure out the data type, and then you create the interactive widget based on a dictionary. So this is why in here, right, the dictionary, and then based on a dictionary to build this one, and automatically. So ipyWidget is very, very powerful. There are a lot more things you can do to create interactive widgets. So hopefully you you can also look at my previous video, how to get started with ipyWidget. This is basically just a combination of all kind of widgets, text box, button, ipy chooser, text box, checkbox, button, something like that. And then you can also click import. Look at the source code if you want to look at my source code if you want to develop something. Okay, so that's all for this video. I hope you enjoy this video, and I hope to see you in the next video. Take care. Bye bye.